Hi, everybody. And now we're up to 3.5, implicit differentiation. And implicit differentiation is one of the most extremely powerful tool that, well, you can do a lot with it. So let's just get right to it. So we have an equation, y is equal to 2 minus 3x squared. And this is a function. And we all know with a function, you have, if you put in an x value, you get a y value. And that's it. Just one x value gives you one y value, and it never gives you it never gives you two y values. If the same x value gave you two different y values, that would fail the vertical line test, and we don't want that. That's not good for a function. But there are certain times when you do have, they're not technically functions, but there are relations which are not actually functions, but they are, things that we see a lot. So instead of giving a whole lengthy definition explanation in theory, I'm just going to jump right into a problem, and you'll understand it a lot better what's going on. So we have a function f of xy is equal to x squared plus y squared minus 25, and we're saying that equals 0. This is basically the same as saying x squared plus y squared equals 25, which, as you know from algebra, is the equation for a circle. We want to find y prime, and we want to find the slope of the graph when x equals 3. So what we're going to do is we're going to go with we're going to put this on the other side. We have x squared plus y squared minus 25 equals 0. We're just going to look at that part right. Let me get my face out of the way. Faces in the way as usual. And that, as you know, is a circle. So what we're going to do now is we're going to say x squared plus y squared minus 25 equals 0. And now we're going to take the derivative of what? I'm sorry. I'm getting ahead of myself. So we're going to plug in x equals 3. And when x equals 3, we solve for y. Y is equal to plus or minus 4. So we want to look at the point 3 comma 4, which is up here, or 3 comma negative 4, which is down there. Those are the different y values for the x value of 3. Now, again, a function would only have one y value for each x value. And as you know, that's the famous vertical line test. This, as you can see, is going to fail the vertical line test. So it's not technically a function, but it's kind of functiony. So we call it, it's like an implicit function. It's not an explicit function, but it's an implicit function, because there is some relationship between x and y. It's not just random. So let's just look here. Now we want to differentiate the equations, both sides, and boing. So x squared plus y squared minus 25 equals 0. And I could consider y to be y of x. Y is a function of x. At least it's an implicit function of x. So I'm going to take the derivative of everything on both sides. So the derivative of x squared with respect to x, the derivative of y squared with respect to x, and the derivative of 25 with respect to x, and of course the derivative of 0. Because if these two things are equal, I can take the derivative of each side, and that'll be equal. Just, it's very similar. It's funny thing, what you learned in algebra when I don't know what grade you did this, 8th grade, 9th grade, whatever. The idea of the algebra equation, you could do, as long as you do the same thing to each side, you're good. Well, here, same thing with calculus. You differentiate each side and you're good. That has its limits, by the way, that idea. But anyway, so the derivative of x squared is 2x. Now, the derivative of y squared, this requires a chain rule, because y is some implicit function of x. I don't know what it is exactly, but it's some function of x. So first we take the outer derivative. We have a y squared. So the outer derivative is 2y to the first power, 2 minus 1, which is the first power, times the inner derivative, which I'm just going to call y prime. Y prime is actually what I'm trying to solve for, but one step at a time. The derivative of 25 is just 0, and of course the derivative of 0 also equals 0. Now, just simplifying this a little bit, just cleaning this up a little bit, I get 2x plus 2y times y prime equals 0. Now, what I want to do is I want to solve for y prime. So all I'm going to do is some basic simple algebra. I'm going to bring the 2x over to the other side. I'm going to divide both sides by 2y. I have negative 2x over 2y, which just becomes negative x over y, which means that if I have any point x comma y on my graph, the slope of the tangent at that point is going to be negative x over y, depending on what the x and y values are. That is very, that's going to make our lives very, very simple, because I just want to now look at the points 3, 4 and the point 3, negative 4. Well, for 3, 4, the slope is going to be negative 3 over 4. And for 3, negative 4, it's going to be positive 3 over 4, because the negatives will cancel on this guy. And by the way, you see the picture kind of bears this out as well, because you see that the tangent line is kind of going down. So a negative slope makes sense. And here on the bottom, the tangent line is going up. So a positive slope makes sense. So actually, this makes a lot of sense just visually. Anyway, that is the story. So the slope. Now, I could ask you what's the equation of the tangent line, and that you would again just use, which we're not asking you that, but that would just be point slope formula, and we'd be good. Let's just for fun, let's do that. I'm going to ask you to find right now. Pause the video and find the equation of this tangent and the equation of that tangent. Okay, everybody, pause your video and solve it. Okay, let's take a look. During the pause, I worked it out here. So at the point 3, 4 and m equals negative 3/4, we have the equation is y minus 4 equals negative 3/4 times x minus 3. And at the point 3, negative 4, we have m equals positive 3/4. So the equation is y plus 4 equals 3/4 times x minus 3. And there you go. Yay for us. Okay, oops, that's not what I wanted. I wanted this. Okay, let's carry on. Differentiate implicitly. Now this, of course, is, who knows. Now the last problem I gave you was the equation of a circle. This is, who knows what kind of funky kind of thing this is. But it doesn't matter. We're just gonna, I'm gonna use that. Maybe we'll use Desmos to see what it looks like. But let's do the strict math first, and then we'll look at the picture. So find the equations of the tangent lines to the graph of y minus xy squared plus x squared plus 1 equals 0 at the points where x equals 1. So we're saying there may be more than one. It's possible that there's more than one. It may just be one tangent, there may be several tangents. I don't know, maybe there's no tangent, I don't know. So here we go. So first we have to solve for y, specifically when x equals 1. So I'm going to just plug in 1 for x, and I get y minus y squared plus 1 again equals 0. Y, which is y squared minus y minus 2 equals 0, which factors into y minus 2, y plus 1. So I have y could be negative 1 or positive 2 when x equals 1. So there are 2 points on the graph where x equals 1. There's 1, negative 1. There's 1, positive 2. The next thing we want to do is find the slope of the graph at these 2 points, and we're just going to differentiate. This is going to be loads of fun. Let's go through it step by step. Y minus, where are we here? Y minus xy squared plus x squared plus 1 equals 0. We're going to take the derivative of each side. So the derivative of y is y prime. The derivative of xy squared. Now this is interesting because this is going to be a product rule, but within the product rule, there's going to be a chain rule. So it's going to be x plus x times 2y times y prime plus y squared. And what happened to the x? Well, this would be the derivative of x, which is just 1. That's why the x kind of disappeared over here. And over here, the derivative of x squared is just 2x. The derivative of 1 is 0, and the derivative of 0 is 0. So I have y. So let's just clean this up a little bit. I get y prime minus 2xy y prime minus y squared plus 2x equals 0. Now I just got to solve for y. So I'm going to bring anything for y prime, I mean. So anything that does not have a y prime in it, I'm going to bring over to the other side, like right here. And now on this side, I'm going to factor out the y prime and divide by anything that's not the parenthesis part that's not y prime. So I get y prime is equal to y squared minus 2x over 1 minus 2xy, and that is y prime. Now we want to find this at the 2 particular points. Notice we have the point 1 comma negative 1 and 1 comma positive 1. Well, at 1, so I'm going to do here for this guy, I'm going to plug in x equals 1, I'm going to plug in y equals negative 1, and I get this whole thing here, which becomes negative 1/3. So that will be the slope at 1 comma negative 1 will be negative third. And here I want where x equals 1 and y equals 2. So I just plug in 1 for x, 2 for y, crunch, 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 and I wind up getting negative 2/3. So negative 2/3 would be the slope of the tangent at the point where of 1 comma 2, and it's going to be tangent to the original graph. Now the equation of the tangent line at 1 comma negative 1. Well, I know the points and I know the slopes. So I'm just going to do point slope. I'm going to do y plus 1 is equal to negative 1/3 x minus 1, because that's the basically on these points, right? These coordinates right here. And crunch, 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 and I get y equals negative 1/3 minus 2/3. And that is the equation of the first tangent line. And for the second tangent line, I'm going to do the same thing. Only this time for y1, I'm going to put in 2 because we have a different point. X1 is still 1. That hasn't changed, because that's what we're talking about, the same x value. And the slope, though, is going to be negative 2/3. Anyway, now just crunch, 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 and I get y equals negative 2/3 x plus 8/3. And those are the equations. Let's see what this looks like. Let's actually graph this guy in Desmos. That should be loads of fun. Let's see. How about, how do I do this? How about, excuse me, folks. Okay, here we go. So let's go to Desmos. And now let me share my screen again with you so you can see what I'm doing. Share the screen again. Here we go. Okay. So here we're back on share screen, and now we're in Desmos. So we want to put in what was the original equation? The original equation was y minus xy squared plus x squared plus 1 equals 0. So y minus xy squared, let's do that. Y minus xy squared. Y minus xy squared. And then plus x squared plus 1 equals 0. Plus x squared plus 1 equals 0. And look at how cool that is. And now we want the point. Let's just look at the point now. Let me get my face out of here. Let's just look at, actually move this over here a little bit. There you go. Now we're looking at the points x equals 1, right? So when x equals 1, that's going to be this guy right there. And that guy right there. So notice that when x equals 1, y is going to equal 2. So that's right there. That's the point right there. 1 comma 2. And that's 1. One comma 2, and I don't need to label that, and 1 comma negative 1. 1 comma negative 1. Okay, so now I want the equations. What were the equations here? So now we're gonna have the equations. So the equations were y equals negative 2/3 x plus 8/3. Let's do that one first. Y equals negative 2/3 x plus 8/3. Y equals negative 2/3 x plus 8/3. 8/3. And look what a beautiful tangent that is right there. Look what a beautiful tangent that is right there. And well, I'm gonna blow this up a little bit. You'll see even more what a beautiful tangent is. And then y equals negative 1/3 x. And what was that one? That was plus minus 2/3, minus 2/3. Minus 2/3, minus 2/3. And look how beautiful that is. And I'm gonna make these guys here. Nice. Oops. We're done. Looks like we're done. And let's blow this up a little bit so we can see even nicer. Look how beautifully this is tangent. See what a beautiful tangent we got there. Look at what a beautiful. So that's the first tangent. That's 1, 2. And here we have the other tangent. Here we have the other tangent. 1, -1. Look how fabulous. And again, the tangent is very, very close to the line itself over here, so it's hard to see the difference, but that is a tangent. That is beautiful. So the Desmos bears out, so the math that we crunched out step by step, the graph bears out the crunchy steps that we just did step by step. All right, beautiful. Let's move on. Let's move on. Okay. Find x prime for x equals x of t. So here x is a function of t. T often stands for time. I'm not saying it has to stand for time in this particular problem, but very often t stands, small t, lowercase t very often stands for time. Uppercase t very often stands for temperature, but it doesn't have to be. I'm just saying it's common. Anyways, so we have t times ln x equals x times e to the t minus 1. Now, like I said before, if you have two variables, I could always try to solve for x in terms of t, or y in terms of x, or something like that. But to try to solve, this is going to be a big mess if I try to do that. So sometimes it's not so easy. Sometimes it's impossible to solve, for one variable in terms of the other. That's why we use implicit differentiation. We don't have to bother trying to solve for explicitly. We just go for the inputs. Okay. We want to evaluate x prime at t comma x equals 0, 1. So the first thing I always do is I plug in 0, 1, see if that's even a solution. Because for all I know, 0, 1 is not even so when t equals 0, well, the left side is just 0 because it's 0, and ln 1, x equals 1, so ln 1 is also 0. So that's just 0. That's double 0. Here, x equals 1 and t equals 0. That's going to be 1 times e to the 0, which is 1 times 1. So it's 1. Minus 1 is also 0. So first, so I always, because you never know. Sometimes they'll say, okay, solve at this point, and then you check and you see the point's not even on the graph. So make sure the point is on the graph by making sure that it satisfies the equation. So that's always, it's always something we want to do. T ln x and x minus e to the t minus, okay. So next, we want to differentiate with respect to t. So here's our original equation. So we want to take now to differentiate this side, I'm going to have to do product rule. Then within the product rule, I'm going to have to do chain rule. Remember, implicit differentiation really uses chain rule. That's why, by the way, implicit differentiation is a very important concept, but I couldn't teach it to you until after you knew chain rule. That's why we had to do chain rule first. And now after chain rule, we're doing implicit differentiation. We couldn't have done it in the other order because implicit differentiation uses chain rule. And I needed you to know chain rule in order to, be able to solve this problem. All right, so the derivative of t ln x, we're going to use product rule now. So it's going to be t times x prime over x plus the derivative of t, which is 1, times ln x. And on this side, I'm going to also have to do a product rules thing. I get x times e prime, and I'm sorry, e to the t plus e to the t times x prime. Now, again, my goal here is to solve for x prime. So I have an x prime over here, and I have an x prime over there. I want to just do what I normally would do in an algebra thing. I want to get the x primes together, factor them out, blah, blah, blah. So I'm going to bring the x prime over to the other side. I'm going to bring the x ln x. Anything which does not have an x prime, I'm going to send over to the right side. Anything which does have an x prime, I'm going to send over to the left side. But now at this point down here, I'm going to factor out the x prime. So I have t minus x e to the t times x prime. I'm going to divide both sides by this parenthesis, and I get x prime is equal to x squared e to the t minus x ln x over t minus x e to the x. Now, this is a big, monstrous looking answer, but that is the correct answer. And that is the correct answer. And it's beautiful because we got rid of, we've now solved for x prime in terms of the other variables. Yeah, it's messy, but all I gotta do is just plug away and I'm good. Now we want to know at the point 0, 1, meaning t is 0 and x is 1. So now I just take this monstrosity here and just plug in 0 and 1, for t and x respectively, and I just get 1 squared e to the 0 minus 1 ln 1 over 0 minus 1 e to the 0, which really just becomes, at the end of the day, it becomes -1. So this whole big giant monstrosity, once I plug in those numbers, I get a very, very simple answer of -1, and that's fabulous. And I love that when you have this big, I love when you have this big monstrous thing, and then you can sort of like whittle it down to something so small and tiny. And that's it. I am out. Well, everybody, it's been loads of fun. And I hope you've enjoyed this fraction as much as I've enjoyed it. And now we're going to signing off from Hogwarts, and we'll see you guys next time. Bye, everybody.